Unidirectional data flow is one of the greatest ideas, in my opinion, of all time when it comes to front-end development in particular. React has popularized this approach, but we don't need to use React to use unidirectional data flow. We'll discuss surgical DOM updates, state management, idempotent rendering, a complete implementation for unidirectional data flow, and refactoring it using ES modules, destructuring, implicit return, and method chaining. But what is unidirectional data flow anyway, and why would we want to do something different than this? The pattern we're using here to implement this mouse move interaction, I would call this surgical DOM updates. What that means here is that the event handler itself, the body of the event handler callback function, is responsible for going in and doing very precise surgery on the state of the DOM. The main drawback here is we have duplicated logic. Here's a chunk of code that sets CX and CY on the circle, and here's another chunk of code that also sets CX and CY on the circle. In this case, it's not that bad because it's such a small, simple example, but try to imagine as things get complex and you start loading in data and having different interactions and visualizing data with charts and graphs that are connected to each other. This pattern, based on many experiences I've had, doesn't scale in complexity. It leads to what I would call spaghetti code, where you have to really work hard to keep track of which parts of code are responsible for which updates, and it gets especially complicated if you have multiple pieces of state. And when I say a piece of state, that's really the X and Y position of the circle in this case. But as you build out programs, you have more and more and more pieces of state to keep track of different things. For example, in this one, the data itself being loaded is one piece of state, and the column that's mapped to X is another piece of state, and the column that's mapped to Y is yet another piece of state. And in this example, the brushed region in this date histogram is a piece of state, or rather, two pieces of state, the beginning and the end, and whether or not it's even brushed. With unidirectional data flow, the changes flow in a circle, in a single direction, and there's one code path that's responsible for rendering everything. This includes the first time it's rendered when the page loads, and it also includes rendering it again and again in response to interaction as the state changes. This diagram sums up unidirectional data flow. The system renders something on the screen, and then the user interacts with that thing on the screen, and that interaction triggers a re-render of what's on the screen. Technically, what happens when you interact is it triggers an event listener for some kind of interaction event that gets fired or emitted. That event listener is then responsible for changing the state or updating the state. In response to changing the state, the system renders an updated version of what should be on the screen using idempotent rendering, which we'll discuss later. I really love this model because the person, the user, the viewer, fits into this model. When something is rendered on the screen, perception and cognition take over. You see what's on the screen, and then you can think about it, and then that translates to volition and action. And this is all taking place inside of a human being. So the human is literally in the loop. That's unidirectional data flow in a nutshell. Let me show you what I mean here in terms of the code. I'm going to fork this viz and just call it mouse follower. I'd like to introduce a pattern here for encapsulating our interactive programs. I'm going to define a function called viz, and this function will accept as input a container, which is the DOM node, and some options. And those options will contain the current state and also a function to set the state. And state will contain x as the x position of our circle and y for the y position of our circle. And then we can take all of this logic for setting up the circle and move it inside of this function. Now cx and cy can be derived from x and y from our state. This viz function can also be responsible for managing the top level SVG. And by the way, this width and height is also a good candidate for putting on the state. That would allow us to handle dynamic resize. Let's wire everything up so this works. We need to invoke this function. So down at the bottom of the file, I'm going to invoke the viz function. We can define the container as, well, what should this container be? I'd like to make this viz function responsible for, the entire interactive visualization part, managing the SVG and whatnot. And then whatever is outside of that should be the responsibility of the code that invokes viz. And so container, really, it's going to be the div with ID of app. So let's select the ID app, just like we did before. But this time, I'm going to access .node, which is the method on D3 selections that gives us access to the underlying DOM element, the DOM node itself. And then we can define options to be an object with two properties, state and set state. The state will be initialized to an empty object with no properties defined. And then set state will be a function. And this function will be responsible for changing the state. But remember, before we can change the value of a variable, it needs to be declared using let, not const. And the state will be really the next version of the state. And next can be a function that gets passed in to set state that accepts as input the current version of the state and then returns as output a new version of the state. For example, when the mouse moves on the screen, in that event handler, we will be calling setState and passing a function that just returns an object with the x and y coordinates from wherever the mouse is. In that case, we don't really need access to the previous version of the state, but sometimes you will need access to the previous version of the state, and that's why I'm going to use this pattern here. After the state is changed, we need to re-render. The term render in front-end development means to update the DOM to be the way you want it to be. I'll define the render function right here to be a function that will invoke our viz. This logic here for invoking the viz, I'm going to move inside the render function. This is it. This is the basic structure for unidirectional data flow. When we set the state gets updated, and render gets invoked. When render gets invoked, we construct the options here using the latest version of the state that was returned from this next function. And we also include a reference to setState, and the definition of setState never changes, but the value of state does. So whenever you invoke setState, next will be invoked with the current version of the state, not any stale old version. And then we invoke our viz function. Notice here that setState is being referenced earlier in the code than it is defined. And there is actually a circular reference here, where setState refers to render, and render refers to setState. This is okay though, it works in JavaScript because of a concept called hoisting. But either way, let's finish this up and make it work by taking this logic that responds to mouse move and moving it into our viz function. And I'll just drop it right here. Instead of directly setting cx and cy, what we want to do is define the next function that we will pass into setState. And this function will return a new object with x and y defined as event.x and event.y. And then we can invoke setState with our next function. Oh, I need to move the declaration of these up here so that we can access it from here. All right, let's see if this works. There are no errors. That's good. Oh, but you know what? I don't think any of this is ever running. Yeah, we need to run it. We need to call render for the first time, like this. Okay, it draws our circle. That's good. Now what happens when we move the mouse around? It doesn't look like it's doing the right thing. Let's right-click and inspect the elements. See what's happening here. It's creating many SVG elements. But that's not what we want it to do. We want it to just create the SVG element once, the first time it runs, and then reuse that existing DOM element in future invocations when it runs again and again. The reason why it's creating so many DOM elements is because we are invoking .append on our app. Oh, and by the way, something I missed earlier, this should be replaced by container. But actually container is a DOM element. So we need to select the container. And you can pass DOM elements as the argument to d3.select, by the way, instead of a selection string. That works. And we want to append an SVG to this, but only the first time it runs. So we need to modify this pattern. D3 luckily has a pattern called the data join pattern, or the general update pattern, that we can use here. And it does exactly what we want. It will append a new DOM element on the first invocation, but on subsequent invocations, it will cause the code to find that existing element and use it instead of creating more and more elements. That goes like this. We have a selection and we call .data. This will set the data part of the data join. And in this case, we just want one thing. So I'm going to pass in an array that just has one element, that element being null. The value could be anything. I'm just using null because I saw that in the D3 axis implementation. And then we say .join, SVG. And that's it. That should do the trick. This will use D3 data join to ensure that our container contains exactly one SVG element. It's quite similar to what React does with the virtual DOM diffing and the JSX. And this pattern in general is called idempotent rendering. The term idempotent means the property of certain operations in mathematics and computer science whereby they can be applied multiple times without changing the result beyond the initial application. Idempotent rendering goes hand in hand with unidirectional data flow. Anyway, let's see if this works. Okay, I'm moving the mouse. I'm not seeing anything. Okay, a circle gets appended to the div directly. I think I missed a step here. Yeah, there's a step where you have to say .select all SVG first. Yeah, there we go. Now there's an SVG inside of our div that has a circle. Yeah, you need the select all just because that's what gives the D3 data join implementation the information of what's already there on the page. So you select all SVG. If there is no SVG yet, then that comes back empty, and this .join operation knows that it needs to mint a brand new DOM element and append it. But if select all SVG comes back with something, and there's only one, then the implementation of .join knows that it doesn't need to do anything. It just needs to return that existing SVG. All right, so what happens now if we move the mouse? Let's see. Ooh, we're creating a trail of circles. Look at that. Isn't that cool? That's just because the way that we're rendering the circles is not idempotent. See, we're just appending a circle every time. We can change this to also use the data join pattern. svg.selectAllCircle.data null.join circle. Now when we move the mouse, the circle just follows the mouse around. All right, that's how we can implement unidirectional data flow for our mouse follower example. It does work, but all the code is in one file, and it could be cleaned up a little bit. So let me just take a little bit of time and refactor the code and clean it up. In this code, we have viz, and then we have the code that invokes viz. This is a really clean border, and it's ripe for using ES6 modules to move this logic out of this file and into its own separate file. So I'm going to copy all this code, open the editor, and make a new file called viz.js, and I will paste this code into here. Now we can export this viz variable out of viz.js so that we can import viz from ./viz. And then I'll delete the version that's inside index.js. And it's not working. Oh, there's a reference error. Select is not defined. Oh, fair enough. We need to import select from D3 inside viz.js. All right, now it works. There are many opportunities here to use more concise syntax. For example, state and set state. Instead of having 2 lines, we can do the same thing on 1 line using what's called destructuring. And we can even do this destructuring right in the arguments like this. This is equivalent to the code we had before, but it's just more concise, but maybe a little more cryptic if you don't know about these language features. Similarly, down here, we don't actually need to put next into a variable. We can just take the body of the function and put it right there as the argument to set state. And also, we can take advantage of implicit return with arrow functions. What that means is if we put something in parentheses like this, that means that it will be implicitly returned, and we don't need to have this return statement. So what we can do is just put this object in here, and we don't need any of that code, and it becomes much smaller. We can also take advantage of method chaining. Instead of setting the attributes in different expressions like this, we can set multiple attributes in one expression by chaining them like this. Method chaining is a fundamental part of the D3 API that you'll see all over the place. And it works because the .attr method actually returns the selection. That's why this code is equivalent to this code here. And instead of putting this in a separate expression, we can actually just tack on those attributes to right after the .join up there. And similarly, state.x and state.y can also be destructured from state. And we can also chain all of these attributes on the circle like this. Now, actually, we don't need this circle variable at all. Just a quick check, it all still works. Let's move on to index.js. We don't really need this options variable. We can just put this object directly here as the argument. And that's it. There is our unidirectional data flow pattern that we will be using for all interaction and all future data viz work that we do in this course.